Now, talking about a fixed payment loan, we say that is the kind of loan that requires the borrower to make equal payments of a stream of cash flows in order to extinguish the full payment of the loan principal and interest by the end of the loan term. And this type of loan is actually common in the mortgage loan market and the personal loan market, whereby the borrower would be asked to spread the payment over some time period. Okay, and we can actually liken it to annuity. So let's take an example and then we look at how to solve it, and then move on to coupon bond. So let's take an example. Let's say if we borrowed a sum of 1,000 Ghana cedis, so amount borrowed is what? 1,000 Ghana cedis. Amount borrowed. If we borrowed this amount from a bank to finance the construction of her new warehouse, and the terms of loan specify that an annual amount of 120 Ghana cedis be paid. This is going to be annual payments. For 10 years. 10 years is the period to defray the total cost, that is the principal plus the interest. We want to determine the yield to maturity of the loan. We want to determine, say, the interest rate. How do we go about this? So this question actually relies on the annuity principles because it involves the payment of equal stream of cash flows, that is 120 cedis every year for like 10 years to be able to defray a sum of borrowed amount at the end of the period. And our responsibility lies in the determination of the interest cost. Actually, there are a number of ways of getting this done, but we are going to use the interpolation formula, which is given by the internal rate of return. We can use the interpolation formula is this: IRR is equal to A plus NPV. NPV is net present value. So NPV of A, then NPV A minus NPVB, and brackets here B minus A. So the IRR is the internal rate of return, which is the rate of return that gives the NPV of 0, or the rate of return that equates the future cash flows to the present cash flows. And the small a is the rate of return that gives the higher NPV, or a positive NPV, and the small b actually is the rate of return that gives a lower or negative NPV. And then NPVA is the net present value when small a is the rate of return, and NPVB is the net present value when small b is the rate of return. So we are actually going to need all the variables in this particular equation in order to apply the formula. And you have to note that this approach to finding the interest rate is based on try and error. So we have to actually try a rate to see if it will give us a positive or negative NPV. So we do try and error to get some value that we can use to test to find the rate for the interest, or rate for the loan that was borrowed. Okay, I mean we are interested in getting the interest rate that we pay on the loan. So we can test that of 10%. We are going to use the present value formula of an annuity. Use present value formula of annuity. You know that for the annuity, the present value is giving us, say, the cash flows, and we have 1 minus 1 plus r exponent negative n all over r. Great. We have different methods that we can use. We have different methods we can use, but in this or in solving this question, let me clean this part so that we can in solving this question. I want us to use the formula that we have here. C, that is the cash flows times 1 minus 1 over 1 plus Rn all over R. This is not different from this, it's the same thing. 1 in indices, if I have 1 over A, it can be written as what? A exponent what? This is A exponent n, can be written as A exponent negative n. A exponent negative n. So it implies that 1 plus R exponent this is the same as 1 over what? 1 plus R exponent n. This is what I'm trying to do. I'm trying to say that it's the same as this one. Okay, so you can either use this or you use this depending on which one looks simple for you. Okay, so given this and that, I want to use this one and I'm going to be consistent with this one, but you can also try with this one which looks simple. So I'm going to solve the question with the values that we were given. So I have my PV. Want to test which MPV, which percentage will give us a positive. So we want to test 10%. Okay, we want to test R being 10%. So we'll say that I have 120. The cash flow is 120. You are paying 120 Ghana cedis annually for 10 years. So I have 120 out. 1 minus 1 divided by 1 plus, I'm using 10%, so 0.1. And the number of years period is what? 10, so n is 10. All divided by the R that I'm testing is what? 0.1. Okay, when I do this and I do simplification, I am going to get 737.348 as my present value. But remember, we are interested in the net present value. So it means that to find the net present value, I have to deduct the 1,000 that we borrowed from this amount. Okay, so minus 1,000, what do I get? I get a negative value, which is negative 262.65196. So when I tested interest rate at 10%, the NPV I got was what? Negative number. So I'll say at R equal to 10%, NPV we are testing is equal to negative 262 point, just want to write the value somewhere, then we'll try another one. Okay, so we need to find an NPV that gives us a positive value. So remember, we said that the B here is the rate at which we get NPV being what? Negative or lower. So since we've gotten a negative one, we can use that for B. We have to get that of A. You have to get that of A. So you can say that, okay, B is 10%. So NPV B is what we've gotten. That is this one. So to get a positive value, we have to also try a guess. We have to guess a rate that when we use, we are going to get a positive value. And we have to also understand that there is an inverse relationship between NPV and interest rate. So if the interest rate is increased, it means that NPV will fall. However, if the interest rate is decreased, the NPV may rise. So since this is a negative value, we can try a smaller interest rate to see if we are going to get a positive value, because the higher the interest rate, the lower the NPV, and then the lower the interest rate, the higher the NPV. So we are going to try say R equal to 2%. We are using this formula. I have PV is equal to 120 times 1 minus 1 over 1 plus what? 2% is 0.02. So 0.02. The N is 10 all over 0.02. What answer do I get when I do simplification? I get 1077.91. So to find the NPV, I deduct my 1,000 initial amount borrowed from this present value I've gotten, and I get a positive value, which is what? 77.91. So I can say that this gives me NPVA, and this is going to be my A. Okay, so it means that I can say A is 2%, and then NPVA is going to be 77.91. Now, having gotten these values, I can now substitute them into this formula, because we are interested in finding the internal rate of return. So when I substitute into the formula, I get 2% plus 77.91 divided by 77.91 minus the NPV B was also negative, so minus 262.65,196 multiplied by B minus A. B was 10, minus A is this. So when we do the calculation, our IRR is going to be 3.83%. So that becomes the interest rate for this fixed payment loan. Now let's go and look at coupon bond. We use coupon bond to also solve a question.